of line complex line integral when contour is a circle. Okay, so see, there is no question as such, but I tried to. There was only one question in previous 5 year, but then took some more papers. Then I found every type of question I could find. Sorry, from reference books and previous year questions. I clubbed them into one question because we are preparing for the worst. So I tried to make the worst question possible. So yeah, evaluate integration log z dz with c as left half of unit circle, x square plus y square equal to 1 from z equal to minus I to z equal to I. So left half of the circle, okay. So this is let's talk about angles. 0, then what would come? Pi by 2. 180 degree is pi. Okay, this is 180 degree, right? 180 degree is pi. Then this is 90 degree. Pi by 2 because it is half of it, right? Then this is pi actually. Okay, 80 degree, 180 degree is equal to pi. 3 pi by 2, 270 degree. This is 2 pi. Okay. So we are talking about left half of the unit circle, this part. Okay. So uh, this is left half of the unit circle. Now we have to find radius. This, okay. Wait a second. I guess focus is gone. Yes. Let's compare the equation. Let's compare equation x square plus y square equal to one to standard equation circle, standard circle equation. Okay. Standard circle equation, which is x square. Oh, two people. Hello, how are you? Nice to see you all. uh, x square plus y square equal to r square. Okay, now if we compare, so x same, y same, 1 is equal to r square, then right, this is only different thing. If you have to know this, right? A is equal to b, okay, and b is equal to c. You must have learned this axiom, right? This axiom says that a is equal to b, b is equal to c, then a is equal to c. Okay, because LHS is equal, then RHS is equal. So what I'm trying to say is that LHS here is equal x square plus y square. Then RHS is equal. Oh, someone liked. Thanks, man. So r square equal to 1. Now root r square is r. Root 1 is 1. So this is 1. R is equal to 1. Okay. Now we know z is equal to, from complex numbers, that z is equal to x square plus y square in Cartesian form. Okay, mod z is equal to root x square plus y square, because we are taking mod of a vector, right? Then it's like this, in under root and sum of the squares. Okay, while z is equal to re raised to I theta in polar form. Okay, we use this because we are talking about angles here. Okay, this would be much simpler, while here it would be x square plus iy square. Okay, because here we are not talking about direction. Okay, but here we are. So this is magnitude, this is imaginary part, this is real part, imaginary part, this is magnitude, this is direction. Okay, because here signs would come, I is coming. Okay, so that's how it works. Now but what is the use of all this? Okay, and also I have to tell you another formula. Log let's say log ma, okay, is equal to m log a. Okay, sorry, log a raised to m is equal to m log a. Okay, because log is actually the reverse of e, like it does reverse of power. Then whatever, because this is a power, like we write log to the base something, right? So this becomes power of that base, but here it is reverse, like this is base, now this is power. Okay, so log actually cancels power, so this is a power, log cancelled it, it becomes a number, like a multiple, like, right, it makes it a number. So you have to remember it like that, it is not actually like that. Okay, this is the formula. Okay, now what else formula can we have? Okay, I have to show you another formula. Oh, 22 people watching, thanks man, really love your support, thanks for watching, thanks for coming man, really appreciate you all. Okay, now integration of uv is equal to u integration of v minus integration of dv du integration of v. Okay, you can also remember it as integration uv equal to u v1 minus u dash v2, right? Hmm, wait a second. Okay, u1 dash v2, sorry, and so on. Okay, plus u to v2, like that. Because see, this one means integration, number of integrations, subscript, and superscript means derivation. Okay, so isn't it like that? And there is another way, integration uv is equal to, like whatever you take u, then integration of v. Okay, then you take minus, then you take a derivative of u, right? Then you take double integration of v, and so on. And that is also a similar thing, right? Because then you would do, and again, like uh, u double derivative, triple integration of v, and so on. Because actually when you are doing this, this is gonna stay the same, but this will change. Now you have to take its integration again, so it's just going ahead. This formula is you have to only repeat this formula, but with this part, then again only this part will remain, but you have to repeat this whole formula only for this part, then again, like that only. Okay, so I think I have shown you most of the formula. Now our question says log z. Okay, log z, let's write it. Log z is equal to log r e raised to I theta. So we found r is equal to 1. Okay, we have found r is equal to 1. So log z equal to log r e raised to I theta. R is equal to 1. Let's substitute this r equal to 1 in that one in this r. Okay, so log into 1 into e raised to I theta. Now I told you log a raised to m is equal to m log a, right? By the way, you have to go through some log formulas though for this. Okay, like log a into log m is equal to log a plus m, something like that. Okay, there are many formulas, you have to go through that. So log r e raised to I theta, then this I theta will come in front of it. Okay, I theta log e. You have to remember log and e are opposite things, like e raised to something while log has base to something, so they are always opposite. Log always makes bases and e always makes powers. So log and e cancel each other, so we get I theta, simple. Okay, Now we have to find for dz. Then first on RHS and LHS both side we have to do derivative of d theta, because we are finding it with respect to d theta. Okay, z equal wait a second, let me do this. Okay, z equal to r e raised to I theta. Okay, told you where it is. Yes, this one, polar equation. Now also I have to say you conjugate of z equal to x plus sorry, this is not okay. Mod z equal to x plus x square plus I square. No. Oh, sorry. Yeah, yeah. Not x square plus I square. What have I done? Wait a second. This is totally wrong. X plus Iy. Okay. Z equal to x plus Iy equal to r e raised to I theta. Mod z equal to root x square plus y square is equal to r. I'm really sorry. I made a huge mistake. Sorry for that. Okay. You got that? I hope so. Yes. Z is equal, conjugate. Conjugate is equal, if z is equal to x plus Iy, then in conjugate we change the imaginary part. Like an arrow is going like this, we change its direction like this. This is going to positive side, this then goes to negative side. Okay, magnitude is same, size will be same, only direction will change. Direction is described by whom? Our imaginary part, I part. I is imaginary part. Okay, because I is imaginary number, iota, root of minus 1, I is equal to root of minus 1, you must be knowing, right? Yeah, so yeah, that's how it is. So we would change imaginary part sign, so that would be x minus iy. Okay, this is how it is. So z equal, but we mostly use this polar part. Okay, z is equal to r e raised to I theta. I'm really sorry for the mistake, sorry. So r e raised to I theta, then we have to take derivative on both side, dz by d theta with respect to theta, because we are trying to convert everything to theta to integrate. Okay, so because z have, we can't solve z that easily. Okay, then r e raised to I theta, because we have everything in angle way, dz by d theta is equal to for r, first things first, r is 1, so 1 into e raised to I theta. Then you have to understand that dz by d by dx x raised to sorry, e raised to x is equal to e raised to x. E raised to x doesn't change, but the problem is if here d by dx, okay, no, some, wait a second, yeah, mm-hmm. Mm, if like if we take derivative, but in the function part, like x raised to n, okay, this is x, there is x raised to something, but there is something extra multiplied to it, then what we would do? Chain rule. Okay, so we would multiply a, same thing we in integration we do uh, opposite, we because integration and derivative are opposite, so we divide that a. Okay, 1 by a into blah 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 blah. Okay, so here it would be x raised, other things would be same. Okay, d by d, dx raised to n by dx, but a would be multiplied now. Okay, while in integration we divide a when we integrate a. Okay, x raised to n. Okay, so now since we have e raised to I theta, here there is theta in denominator with respect to d theta we are doing, so here is theta, no problem. But the problem is I. Why I is there? Then that extra part we will just multiply. Okay, but e raised to I theta remains e raised to I theta, there is no problem. but we would multiply I here because there was I extra, so it comes in multiplication, okay, the extra part, which is multiplied with our function which we need to take derivative, okay. Dz, here d theta, okay. Here it is dividing, I sent to multiply here because when we transpose we make it opposite sign, okay, opposite operation. So here there is log z, here is there is dz. Now we found most of it, log z dz integration we had to take, we have it now. Now we have to take is we have to evaluate log z is I theta integration I theta. Now this is I e raised to I theta, okay, I e raised to I theta d theta. We always take d theta when we take integration, right? That is always it is. Oh, 16 people, one like. Thanks, man. Thanks for the like. I really appreciate you all. I'm really grateful for such a lovely audience. Thanks, man. For 16 people watching, thank you very much. You make my day like way better. Thanks, man. So, since the like I have to show you integration k into x, so this constant goes ahead, okay, it multiplies as it is to the integration, we don't have need to take its integration, okay. So now there is what is common in between these, I is common, okay. Theta is theta is different than e raised to I theta, okay. You can't take those common, like theta you can't take common, that's in multiplication, and in raised to that is very different. Here it is in multiplication, here it is in raised to, that too multiplied by I, okay. So we have to take I common. Now I is a constant, so what did I tell you, like when there is a coefficient which is a constant, which is a coefficient, integration of a coefficient into a function, we can take the coefficient outside and multiply it later directly to the integration of these, okay. So I took it common I, then I theta, I gone, theta remains. Now I gone from here, only e raised to I theta remains, d theta. Now theta into e raised to I theta. Now what we have to do, this is uv integration rule we have to use, I told you here, okay. There are three ways to remember it, you can remember any you like. Now I into, by the way, did you understand like which angles we have to take? See, we have from z equal to minus I to I, so this is your 0, yeah 0, no, this is 0, this is 1 I, like see, x plus iy, no, so I is here in imaginary part, in y part, so y axis we have I, here it is 1, so we have 1, okay. In x axis x is 1, so x axis 1, real part 1, imaginary part I, and it is imaginary, so there is gonna be I, ha. So what we have opposite of 1, simple, minus 1. What we have opposite of I, minus I. So it is the you have to look at the corresponding angles, because we are taking theta here, so we can take angles here, theta is an angle, we can only replace it with angles. So what angles we have corresponding to I and minus I, 3 pi by 2, pi by 2, simple. Now minus I means 3 pi by 2 to pi by 2, so now here to here, okay. This is the limit we have, so I would write the limits here, 3 pi by 2, 2 pi by 2, wait a second, pi by 2, yes. Now we would see there is a Liet rule when you take u and v, okay. I would tell why Liet rule is, because in Liet rule you have exponential at last. So I would tell you what Liet is. Liet means logarithm, log, inverse, algebraic terms like x, y, theta and all, trigonometric, exponential. So this is the priority for taking you. Hi, April Bradley, U4G. What's up, man? Really glad to meet ya. Hi. Hi. What's up? Thanks for coming, man. Welcome to the stream. Thanks for joining. How are ya? Days good? Wait a second. Something came up. So I would continue this later on, okay? So this is for taking you. I would explain later on. Sorry. Yo, good. Can you come later, please? Something came up, so I have to go. Sorry to stop the live now. Bye. Thanks for like, share, subscribe.